Hey everyone, I'm Hussein and welcome to a new video on the YouTube channel. In this video, we're going to model this villa you're seeing on the screen right now. If you remember, I previously made a video about modeling a residential floor plan. That video got way more attention than I expected, and a lot of you asked me to continue making content in the same style. So I decided to turn this into a series. But this isn't just going to be a basic tutorial. The goal is to gradually move toward more realistic, more complete, and more complex projects. So beginners can still follow along, but at the same time, more experienced users can also pick up useful techniques and insights. In the previous episode, we focused more on modeling the interior of a residential plan. But this time, we're stepping into a villa project, a more complete design with more detail, and of course, more interesting challenges. This villa is a single-story flat structure with 2 bedrooms inside. It also has a terrace that connects directly to the outdoor space. And the site itself isn't completely flat. There's some topography and elevation changes, which makes the model feel much more natural and realistic. On the other hand, one of the most interesting parts of this project is the A-frame roof. It's not only visually appealing from an architectural point of view, but also brings some really interesting modeling challenges. Inside the villa, there's also a central void with a tree growing right through it, meaning nature literally becomes part of the interior space. And that gives the whole project a very unique character. On top of that, there are several smaller but important details throughout the model, which we'll discover step by step as we work on it. In this video, I'll try to keep everything as simple, smooth, and understandable as possible. Even if you're just starting out, you'll still be able to follow along and build the project step by step. So if you're ready, let's start modeling this villa. All right, let's start the modeling process. I've already prepared the AutoCAD file of this villa's floor plan, and we're going to build everything directly based on it. I'll also leave the download link in the description, so if you want, you can download it and follow along step by step with the video. First of all, I'm going to set up the project units. In this project, I'll set the units to meters because for architectural work, meters usually feel more natural and consistent in scale, but you're not limited to this. You can use centimeters, millimeters, or any unit you're comfortable with. The only important thing is this: decide your unit at the beginning and keep it consistent throughout the project. Otherwise, you'll run into scaling issues later during modeling or rendering. Now I simply drag and drop the AutoCAD file into the Rhino workspace and choose Import. As you can see, after confirming the settings, the plan is now placed inside Rhino and we can use it as the base for our modeling. Before jumping straight into modeling, I want to do something important that will keep the project clean and professional. I create a new layer called AutoCAD and I move all the imported CAD layers into it, just like I'm doing on screen right now. This might seem like a small step, but in real projects, proper layer management is extremely important because as the project grows, without a clean structure, your file can quickly become messy and hard to control. Now I lock the AutoCAD layer. This keeps the drawing as a fixed reference in the background, so it won't get accidentally selected or moved. It's a simple habit, but it prevents a lot of mistakes and unwanted changes and helps keep your workflow clean, fast, and professional. And now that everything is ready, we can move on to the main part and start modeling the villa. Let's move on to modeling the walls. Before I jump straight into the modeling process, I want to briefly explain the logic behind it, because in Rhino, there are several different ways to approach walls, and everyone tends to prefer a slightly different workflow. In architectural modeling, the most important thing is not necessarily using one specific method. What really matters is reaching a clean, controlled, and correct final model. One of the most common approaches is this. You start by drawing closed curves directly from the floor plan to represent the walls, and then you extrude them to turn them into volumes. After that, elements like the areas above windows, below windows, and door lintels are modeled separately using the same logic. This method is simple, clean, and works very well for architectural projects. Another approach is to model the entire wall as a single solid. In this method, you first create a full mass of the wall and then subtract the openings for doors and windows. To do this, you usually model the openings as boxes. Each box is created with the exact dimensions of the door or window and then placed precisely in position. The important thing here is that the box must fully intersect the wall because it's going to be used for subtraction. Then, using the Boolean difference command, you subtract those volumes from the wall and the openings are created automatically. This method is also very common, especially when you want a faster workflow or expect a lot of changes in the openings. On top of that, you can also use different plugins. If I had to mention one for this video, Visual Arc would be a good choice. This plugin basically brings some BIM and Revit-like capabilities into Rhino. For example, with the wall tool, you can quickly draw walls and add doors and windows in a more structured way. For some projects, it can be significantly faster, but of course it has its own pros and limitations. For instance, it reduces some of Rhino's freeform flexibility, but in return, it automates a lot of tasks. However, for this tutorial, I'm going to use the first method because it's simpler and it's much better for understanding the logic of architectural modeling inside Rhino, but you're free to choose whichever workflow you're more comfortable with. In general, when it comes to modeling, any method that eventually leads you to a clean and correct model can be considered a valid approach, even if it feels a bit unconventional at first. All right, let's continue with the project. First, I create a new layer called Wall and set it as the active layer, so all the wall geometry will be organized inside it. Then I start drawing the wall outlines directly from the plan using the polyline command. This is where that locked AutoCAD file becomes really useful. It acts like a clean underlay, always staying in the background as a reference. If your snaps are properly enabled, this step becomes very fast and smooth, just like what you can see on the screen. Once all the closed wall curves are drawn, I extrude them using the extrude curve command to turn them into 3D volumes. For now, I set the wall height to 2.8 meters. Next, we need to model the upper parts of the windows as well as the door lintels. For the window heads, I first draw a closed rectangle, as you can see here. Then I use the gumball tool to move it up to around 2.3 meters. After that, I extrude it up to the full wall height. This value is just temporary, and it might change later in the project, so don't get too focused on exact numbers at this stage. Sometimes during modeling, you might accidentally move or misplace a surface. To fix that, as you can see, I simply hold Ctrl and Shift to select the specific face and then use the Move command to adjust it easily. This is one of the great advantages of Rhino. You can edit parts of the model without breaking the entire geometry. Now I repeat the same process for the doors. For the door lintels, I set the height to 2.1 meters and extrude that section as well. After doing this for all doors and windows, we move on to the lower parts of the windows. I model the windowsills using exactly the same method. For now, I set the height to 20 centimeters and apply this to all windows. This completes the basic form of the walls. All right, let's move on to modeling the villa floor. First, I create a new layer called floor and set it as the active layer, so everything related to the floor stays organized in one place and the file remains clean and structured. As you can see on the screen, I start drawing the main boundary of the villa using the polyline command. I make sure all the curves are fully closed because we're going to extrude them later, and if there's any gap in the curve, the volume might not generate correctly. Inside this villa, we also have a central void designed for a tree. I draw that part separately as well, so it remains empty inside the floor later and creates that connection between nature and architecture. Once the curves are ready, I select both of them and extrude them to create solid geometry. For now, I set the floor thickness to 20 centimeters. At this stage, our focus is mainly on the overall form and modeling process, not detailed construction accuracy. So there's no need to worry too much about precise structural thickness or technical details right now. Everything can always be refined later if needed. Now I repeat the same process for the entrance path and the terraces. You might wonder why I'm modeling these parts separately instead of creating everything as one single surface. The reason is simple. I'll probably assign different materials to each area later. For example, the interior floor might have one material, the terrace another, and the entrance path something completely different. So separating them from the beginning makes material management much easier later on. Of course, this is not the only way to do it. You could also model everything as a single surface and then separate it later using split or even Boolean split. In terms of final result, there's no major difference. It mostly depends on your workflow style and how you prefer to manage your project. So up to this point, we've modeled the interior walls and also the floor of the project, and slowly the overall shape of the villa is starting to take form. All right, next step is modeling the roof of the villa. First, I create a new layer called roof and activate it so everything related to the roof stays organized inside this layer. To start, we basically follow a very similar logic to what we did for the floor. That means we first draw the roof boundary as a closed curve. But this time, instead of keeping it on the ground plane, we move it up to the top of the walls. So I select the roof curve and using either gumball or the move command, I bring it up to the 2.8 meter height level. After that, I extrude it to give it thickness. For now, I set the roof thickness to 40 centimeters, just like what you can see on the screen. So up to this point, we've created the main flat roof of the project. But as we mentioned earlier, part of this villa is designed with an A-frame roof. And now we're going to model that section. The idea here is slightly different from a flat roof. Instead of just extruding a single surface, we need to think in terms of geometry that slopes and meets at a peak. So I start by defining the main edges of the A-frame based on the plan and the structural logic of the design. Then I create the guiding lines that represent the slope of the roof. Once those curves are in place, we can build the roof surfaces by connecting them and shaping the form step by step. At this stage, I'm not focusing on perfect detailing yet, but on getting the correct overall mass and silhouette, because once the main form is correct, refining the geometry later becomes much easier. And just like that, the roof starts to become a key architectural element of the villa, and the overall design begins to feel complete. To start, I first isolate the area of the pitched roof by drawing a separate rectangle and place it directly on the roof surface. Then I draw a simple guideline from the center of this rectangle. This line is only a modeling reference, helping us define the roof form more accurately. Now using the gumball tool, I move this center line up to the desired height of the A-frame roof. In other words, this line defines the peak point of our pitched roof. Based on this, I draw a triangular section exactly like what you can see on the screen. This section represents the main profile of the A-frame roof. Once the profile is ready, I extrude it along the length of the roof to generate the main A-frame volume. So now we have the basic form of the pitched roof, but it's still not fully detailed. On the northern side of the villa, there is a recessed cut in the roof that we need to create. To do this, I first define that area using another rectangle. I intentionally make it slightly larger and taller than needed so that the Boolean operation works cleanly and ensures it fully intersects the roof volume. Then I extrude this rectangle. But here's an important detail. Since the roof is sloped, a straight vertical extrusion would not produce the correct result. So inside the extrude settings, I enable the direction option and manually align the extrusion direction with the slope of the roof, just like what you can see on the screen. After creating this volume, I use Boolean difference to subtract it from the A-frame roof, and that creates the roof recess. Now we move on to the attic entrance. For this part, I create a box to define the opening for the access door. I set its width to around 1.2 meters and extrude it up to a height of 2.1 meters. Then, I position the box so it properly intersects the roof, both in terms of placement and overall form. Once it's correctly aligned, I use Boolean difference again to subtract this volume from the roof. This creates the actual opening for the entrance. So now, the basic form of the A-frame roof is complete, and the main structure of the pitched roof is fully defined. In the next step, we'll start adding more details to make the roof feel more realistic and refined. Before we continue with the pitched roof, I also want to create the initial form of the parapet for the other part of the roof. This will allow us to later model its details as well as the flashing elements. For now, I'm only focused on the basic mass, so I start by drawing a simple line within the parapet area and then extrude it up by 80 centimeters to create the initial volume. But since the roof is sloped, part of this volume needs to be adjusted. So I select the edge I need using Control and Shift, and then move it up until it aligns with the sloped roof surface, just like what you can see on the screen. Now let's go back to the main pitched roof. To work more efficiently, I select the roof volume and isolate it. This temporarily hides everything else in the model. This is especially useful in complex projects because it helps you focus only on the part you're working on. So now we have a complete solid volume, but this is not the form I actually want. The goal here is to convert this roof into a shell with a defined thickness. So I hold Control and Shift and select the bottom face of the volume, then delete it to remove the lower part. Now, I draw a line over the roof surface using the polyline command, just like what you can see on the screen. Then I offset this line by 2 centimeters. The reason is simple. I want the thickness of the roof shell to be 2 centimeters. After that, I take the same curve again and apply another offset, but this time I set it to 15 centimeters. This second offset is used to define the profile of the A-frame beam. There's an important detail here. If you set the cap option in the offset settings to flat, Rhino will give you a closed curve automatically, which makes the process much easier. Now I click on the resulting curve, so the control points become visible, and I start adjusting the shape, just like what you can see on the screen. If you are using older versions of Rhino, like Rhino 5, the control points may not appear automatically. In that case, after selecting the curve, you can simply press F10 on your keyboard to show the control points. Now the beam profile is ready. I extrude it by 10 centimeters to turn it into a solid beam. Then I copy this beam across different parts of the roof with reasonable spacing. The overall roof form itself helps a lot in deciding where the beams should go. So you don't need to obsess over exact measurements here. You are mainly shaping the architectural logic of the form. Now the beams are done as well. The only thing left is the outer roof skin, which I want to give a real thickness. For this, I use the offset surface command. I set the thickness to 2 centimeters to create the roof shell. If the offset direction goes the wrong way, you can simply use the flip all option in the command settings to reverse it, just like what you can see on the screen. And with that, our pitched roof is now complete. All right, let's move on to modeling the site terrain. First, I create a new layer called ground and activate it so everything related to the terrain and site modeling stays organized inside this layer. Inside the AutoCAD file, layer number 3 contains the contour lines of the site. To keep the workspace clean, I temporarily turn off all layers and only keep the contour layer visible. This helps us focus only on the terrain lines and reduces the chance of mistakes while tracing. Now, using these contour lines, I start recreating the full set of terrain curves. For this, I use the interpolate curve command, because this command gives us smoother and more natural curves, which is usually a better choice for terrain modeling. I draw the curves one by one, and even for the start and end boundaries of the site, I define straight lines so the terrain area is fully enclosed and we don't run into issues later when creating surfaces. Now that all curves are ready, I select them all. Then I deselect the first curve by holding Control and clicking on it. After that, I use the gumball tool to move the remaining curves down by 5 centimeters. Then I repeat the same process again. This slight offset helps create better separation between contour levels and prepares the geometry for surface generation in the next step. This time, I deselect the next curve and again move the remaining ones 5 centimeters down. I continue this process until all the curves are adjusted, just like what you can see on the screen. What we've done here is actually creating the height variation between contour lines. So each curve is positioned 5 centimeters lower than the previous one, which gradually defines the real topography of the site. Now that the vertical positions are defined, we can convert these curves into a surface. There are different ways to do this, but in this case, after selecting all the curves, I use the loft command. And as you can see, Rhino generates the terrain surface based on the contour lines. So now we have the ground of the project. Next, I go back to the villa floor that we modeled earlier. Since the real terrain is now defined, I want to adjust the height and thickness of the floor accordingly. To do this, I use Control and Shift to select the bottom face of the floor and move it down until it matches the desired elevation and thickness. The goal here is to make the main volume of the villa sit properly on the ground, so it feels naturally connected to the site. But for the terraces, I intentionally create a slight cantilever effect, so they feel lighter and more floating. This contrast between grounded volumes and cantilevered elements makes the overall composition much more interesting. So now the terrain is complete as well, and the overall space of the villa is becoming much more defined. Next, we'll move on to modeling the interior spaces of the villa. If you found this video helpful so far, make sure to like the video and subscribe to the channel, because in the next parts of this series, we're going to keep developing these projects step by step, making them more complete, more detailed, and more professional. All right, let's continue. Now let's move on to modeling the windows. For the windows, and also a large part of the interior furniture and objects in this project, I'm going to use pre-made assets. For this video, I've prepared a separate file that includes all the objects used in this villa. I'll share that file with you as well, and the download link will be in the description, so if you want, you can follow along with the exact same assets. All right, let's start with the windows. First, I create a new layer called Window, so all window-related objects stay organized in one place and the project remains clean. Now I go into the object file, select the window I need and copy it using Ctrl and C. Then I come back to the main project file and paste it using Ctrl and V. Now I just need to position it correctly using the Move command, just like what you can see on the screen. After that, for the other similar window locations, I simply duplicate it and place copies wherever needed. This way, we quickly populate the building without having to remodel every single window from scratch. Now I move the window object into the layer I created. To do this, after selecting the object, I right-click on the target layer and choose Change Object Layer so the window gets assigned to the window layer. This might seem like a small step, but in larger projects, proper layer management is what keeps everything clean and controllable. Now sometimes, like what you can see on the screen, the window size might not be exactly what we need. Maybe the frame is too wide or too narrow, or some parts need adjustment. In cases like this, I first isolate the window so I can focus on it without distractions. Then, holding Ctrl and Shift, I drag from left to right to select the part I want to modify. Now I can easily adjust it using Move or Gumball, just like what you can see on the screen. This method is very useful for editing many types of objects, and it saves you from rebuilding things from scratch every time. In other words, whenever you need to slightly adjust a form, you can simply modify it using this logic. At this point, I realized I had forgotten to model the lower part of the master bathroom window. So I quickly fixed that and placed the corresponding window there as well. But the window I just placed is slightly larger than what this space actually needs. So I copy it again and repeat the same resizing process to make it fit properly. Now, using this same workflow, I continue placing all the windows of the villa one by one. Before moving on to the doors, I take a moment to review the overall model, and I feel that the height above the windows is slightly too large. I think reducing it a bit would improve the overall proportions of the project. This is completely normal in architectural modeling. After seeing the full volume, you often realize that some proportions need adjustment. So I select all the windows and isolate them. Then, using Ctrl and Shift, I select the upper connection area between the windows and the wall, as well as the top frame. Remember, every selected part can be moved and edited. Now I move that section up by 20 centimeters to correct the window height. And honestly, the proportion feels much better now. Alright, let's move on to the doors. For this exercise, I've included two different types of doors in the project. One is the main entrance door of the villa, and the other is for the interior doors. Of course, you can add more variety if you want, and use different door models throughout the project, but from a modeling workflow perspective, there's not a big difference between them. It's really just a matter of which asset you're using. So let's start with the main entrance door. Just like we did with the windows, I import the door from the object file into the project and place it in the correct position. But as you can see, the size of this door is slightly larger than the frame we have in the model. To fix this, we have two options. We could either use the same manual editing approach we used for the windows and adjust parts of the geometry directly, or we can use the Scale 1D command. Since I want to show both methods in this video, this time I'm going with the second approach. As you can see on the screen, using Scale 1D makes it very easy to adjust the length of the door to match the frame dimensions. This command is especially useful when you only want to modify a single direction of an object without affecting its overall form. After adjusting the size, I simply use the Move command to place the door in its correct position. For the interior doors, I follow the exact same workflow. I import the object into the project, place it in the right location, and if any adjustment is needed, I use one of the two methods we discussed earlier, either direct surface editing or Scale 1D. Now I repeat this process for all the interior doors of the project until all spaces are properly defined. Finally, to keep the file organized, I create a new layer called Door and move all door-related objects into it. This keeps the project much cleaner and easier to manage, especially as it grows larger and more complex over time. Now we move on to modeling the garage door. This door is a rolling shutter type, which is commonly used in parking spaces. The first thing I do is isolate the upper part of the wall where the garage door is located. This is just to keep the workspace cleaner so I can focus only on this section and model it more precisely. All right, now let's start building the door itself. The first element we need is a spiral. In Rhino, if you right-click on the spiral command, you can choose flat spiral. That's exactly what we need here. Now I start drawing the spiral. I set the radius to 20 centimeters and the number of turns to 4. So the rolling behavior of the door is clearly defined. After creating the spiral, I switch to the front view and rotate it so that the edge of the spiral faces outward. This step is very important because it defines the direction the door will roll. Next, from the end of the spiral, I draw a straight vertical line downward. This line can go all the way to the ground, or it can be shorter, depending on whether we want the door fully closed or partially open. In this case, I extend it all the way to the ground to simulate a fully closed door. Now, I join these two curves together so we have a single continuous curve. After that, I use the offset command and set the caps option to flat to give this curve a 2 centimeter thickness. In fact, this step defines the main profile of the door. Now I extrude this profile to turn it into a solid volume. And as you can see, the basic form of a rolling shutter garage door is starting to appear. This is a simple base model of the parking door, and later we can add more details to it, like rails, the upper housing box, or the rolling mechanism. But at this stage, the goal is just to create a clear and usable base form that we can already place inside the project. All right, let's move on to the next part. Inside the garage, I've designed a small work counter, which is used both for placing tools and as a compact workspace for basic mechanical tasks. Now, I want to model this area. Before starting, I want to mention something important. In this video, I don't want to go too deep into detailed interior design or furniture modeling, because in reality, each of these spaces can easily become the topic of a full separate video on its own. Also, I don't want this video to become unnecessarily long or shift focus away from the main goal, which is modeling the overall villa. The purpose of this video is mainly to understand the overall modeling workflow and how this villa is built step by step. So if you're interested in learning interior design in more detail, I already have separate dedicated videos on many of these topics in the channel. For example, I've uploaded 2 separate videos about kitchen modeling and cabinet design, which I highly recommend watching. I'll leave the links in the description and also show them on the screen. All right, now let's get back to this section. First, I select the wall related to the garage work area and isolate it so the workspace becomes cleaner and I can focus more easily on this section. Then I create a new layer so that all cabinets and elements of this area stay organized inside it. I name this layer Close It. First, I'm going to build the main counter. For this, I create a box matching the dimensions of the defined space, and I set the countertop thickness to 5 centimeters. Then, using the gumball tool, I move it up to 90 centimeters so it sits at a proper counter height. Now, underneath this surface, we need to build the cabinet structure. I start with the base panel of the cabinet. I model a wooden board with a thickness of 2 centimeters and a height of 14 centimeters. To create it, just like before, I draw a closed polyline and extrude it. Then I move this panel 5 centimeters inward, so it sits slightly recessed behind the cabinet doors and gives a more realistic depth. Now on top of this section, I model the cabinet base floor, just like what you can see on the screen. Next, I move on to the vertical divider panels inside the cabinet. These elements define the internal structure and make the compartment divisions feel much more realistic. In the middle section of the cabinet, I also add a few small shelves so there's space for storing tools and smaller objects, just like what you can see on the screen. Now, to ensure the doors sit correctly later, I use Ctrl and Shift to select the edges of the internal panels and offset them inward by about 2 centimeters. This creates a proper recess, so when we add the cabinet doors, they align cleanly with the main body, and the result looks much more professional. All right, now let's move on to the cabinet doors. I model them using the same logic as before, following the same basic workflow. The only important detail here is that I leave about a 1 millimeter gap between the doors. It's a very small distance, but it helps define the separation lines and makes the model feel more realistic and detailed. Now that the doors are done, I move on to the wall-mounted shelf. For this part, I use the same approach as before, modeling a simple panel for the shelf, and then lifting it up about 50 centimeters to place it at the correct height. To make the connection to the wall feel more structural and believable, I add a few triangular support profiles underneath it, giving it a more engineered and logical appearance, just like what you can see on the screen. And of course, you can customize this section however you like and adjust the design or detailing based on your own style and preference. Now let's move on to the master bedroom corridor wardrobe. For this part, I want to design a wooden lattice shelving system that provides storage space while also making the space feel lighter and more modern visually. To start, I create a panel with a 2 centimeter thickness and set its height to 2.5 meters, just like what you can see on the screen. Now, I duplicate this panel along the length of the wardrobe with a fixed spacing. The spacing I use here is 60 centimeters. For both sides of the wardrobe, I keep this spacing consistent and then use the mirror command to duplicate the opposite side so the structure becomes fully symmetrical. The middle section, however, I intentionally make slightly wider because I want that area to have a more distinctive visual character. Now I move on to the horizontal panels, or the shelves. I place them at regular intervals to complete the overall shelving structure. After that, I use Boolean split to cut the panels relative to each other and remove the unnecessary parts, just like what you can see on the screen. The reason for this step is that I want to create a more special composition in the central section, almost like a small counter or a feature space, so the shelving doesn't look completely uniform and repetitive. Now that the overall form is complete, to make sure none of the panels are intersecting incorrectly, and to clean up the geometry, I select all the elements and use Boolean union to turn everything into a single unified solid. And just like that, the lattice shelving is done. Now let's move on to the wardrobe in the adjacent room. First, I switch to the wall layer and draw a new wall segment in this area to define the boundary of the closet space. Then I return to the closet layer and start building the wardrobe frame. For this, I draw a closed polyline, offset it by 5 centimeters, and then extrude it by 2 centimeters. This creates the main frame of the wardrobe doors. Next, I divide the interior of the closet using 2 centimeter thick panels to form the shelving system inside, just like what you can see on the screen. After completing the internal structure, I move on to the wardrobe doors. Using the same method as before, I start modeling the doors. I make sure the gaps and spacing feel natural so the model looks clean and realistic. And in this way, we get a simple but functional wardrobe for this room as well. Finally, I review the entire model once again and fix any areas that need adjustment. For example, right here, as you can see, I slightly move the wall so it aligns more accurately with the wardrobe door, making the final result cleaner and more precise. Now let's move on to the shoe cabinet and entry storage unit, located right next to the main entrance of the villa. I'll try not to repeat myself too much here, because the modeling process is basically the same as the wardrobes we built earlier. In fact, the core logic is still the same. A combination of simple panels and box elements that come together to form the final cabinet structure. So this time I'll focus more on showing the workflow itself and avoid going into repetitive explanations. I'm also not cutting the video here, so you can clearly see the continuity of the modeling process and how each form develops step by step. As you can see, I'm using exactly the same approach we used for the previous wardrobes and the garage work counter. Vertical panels, internal shelves, and doors are all created using the same logic. The only difference is the scale and proportions, which are adjusted based on this specific space. And that's it. The entry shoe cabinet is being built using the same consistent modeling strategy throughout the project. All right, let's move on to the next step, modeling the baseboards. First, I create a new layer called Cornice and activate it so all baseboard elements stay organized in this layer. For modeling the baseboards, I'm going to use the sweep one rail command. This method is very efficient for creating elements that follow a constant profile along a path. The profile I choose for the baseboard is a simple rectangle with dimensions of 10 by 2 centimeters. But before running the sweep, we need to define the path of the baseboards. So I start drawing the routes using the polyline command along the areas where baseboards are needed. I make sure to only draw where they are actually visible and required in the design. As you can see on the screen, I trace these paths one by one along the walls. Now that all the rails are ready, I first select the baseboard profile, the 10 by 2 centimeter rectangle, and then select the corresponding rail. Then I apply the sweep one rail command, and the baseboard is generated automatically. I repeat this process for all the paths we created until all baseboards in the space are completed. Now let's move on to modeling the kitchen. As I mentioned earlier, I already have 2 separate videos on the channel that focus entirely on kitchen modeling. So if you're interested in learning more detailed cabinet design and professional kitchen workflows, I highly recommend watching those after this video. But for this project, the goal is to create a simple, clean kitchen for the villa without making this video unnecessarily long. So I create a new layer called kitchen, and I'm going to model everything related to the kitchen inside this layer. All right, let's start building it. Since we've already repeated many of the modeling workflows in this video, I'll try to avoid unnecessary repetition and move a bit faster here. The kitchen modeling system is very similar to the wardrobes and the garage counter we built earlier. So, first, I start with the countertop. I model the countertop surface and then move it up to 90 centimeters so it sits at a standard working height. Now we move on to the lower cabinet space. Based on the layout I defined in the plan, I start creating the base cabinet boxes one by one. First, I create a box for the space under the countertop with a height of 14 centimeters from the ground. Then, just like we did in the garage cabinet, I place a wooden panel from the floor up to 14 centimeters with a 5 centimeter inward setback. And I continue this same process for the rest of the kitchen cabinetry. As before, I won't cut the video here so you can clearly follow the continuity of the workflow and see how the entire process develops step by step. Now, I import the refrigerator into the project and place it in its correct position. After placing it, I realize I need to adjust the cabinet dimensions to properly match the fridge. So I lock the refrigerator first, so it doesn't move accidentally during editing. Then I use Control and Shift to select the parts I want to modify and reposition them so the cabinet dimensions align correctly with the fridge. Now I continue modeling the remaining cabinets as well as the cabinet doors. Next, I move on to the main kitchen appliances. I bring the stove into the project and place it in the correct location. Then I import the hood and position it above the stove. As you can see on the screen, I slightly adjust the hood dimensions to better match the scale of the kitchen and cabinets. Now we move on to modeling the sink. For the sink, you can absolutely use a pre-made model, but in this case, I want to model a simple rustic sink ourselves. Luckily, the sink is not very complicated to build. First, I use the polyline command to draw the outline of the sink directly on the countertop surface. I make sure the curve is closed and slightly offset it about 1 centimeter upward so the placement becomes more precise. Then I extrude it downward by about 20 centimeters to create the initial volume of the sink. But as you can see, this volume intersects with the cabinet underneath. So I use Boolean split to subtract this shape from both the countertop and the base cabinet below it. Then I select and delete the unnecessary parts. After that, I use Control and Shift to select the top face of the remaining box and remove it. And just like that, the basic form of the sink is created. Now, to give the sink real thickness, I use the offset surface command. I offset the inner surface by 2 centimeters inward to generate the wall thickness of the sink. If the direction is incorrect, you can simply use the flip all option to reverse it. These small details become very important during rendering because lighting and shadows help make the sink feel much more realistic. Now let's move on to the faucet. For the faucet, I use a pre-made object. I copy and paste it into the project and then place it precisely using the gumball tool. After that, I slightly adjust its scale so it matches the sink proportions better and feels more natural in the scene. In this way, the sink is now complete both in form and in detail. Finally, I bring in the rest of the kitchen objects, like the counter chairs and small accessories, and place them in their correct positions. And that's it. This is the kitchen of the villa. Finally, I bring in the remaining furniture objects that we need and place them in their correct positions inside the project. I do this for the bedroom beds as well as the living room furniture. Just like before, I simply import the objects and use Move and Gumball to position them accurately in the scene. If any of them need size adjustments, we can easily modify them using Scale or by directly editing the geometry. For the TV room, I first create a simple floating TV unit using a basic box. It's connected to the wall and has a very minimal design, but for this stage of the project, it's completely enough and also gives a modern feel to the space. Then I import the TV object and place it on the wall above the unit. Now we go back to the rooftop. Before continuing, I want to add a frame and a glass roof to the central void space where the tree is located. To build it, I first draw the structural frame and then extrude it to create the main form of the glass roof structure. And just like that, the central space of the villa starts to feel more complete and realistic. Now let's move on to the attic room. For this section, we haven't placed the entrance door yet, so I'm going to complete that part as well. First, I need to create the opening for the door inside the roof volume. So I draw a box matching the size of the door and use it as a cutting volume. Then I apply Boolean difference to subtract this volume from the roof and create the opening. Now I take one of the interior doors from the project and move it into this area, placing it in the correct position. After that, I slightly adjust its dimensions so it fits perfectly within the space. And now, this section is now complete. Now only the parapet and roof flashing remain, so let's finish those as well. To start, I draw the parapet path using the polyline command. This time, I apply a 20 centimeter offset, and since the caps option is set to flat, I get a closed curve that I can extrude by 80 centimeters. Now using Ctrl and Shift, I select the relevant edges and align them with the slope of the pitched roof so the parapet body takes its final shape, but we still need the flashing. To create it, I use the duplicate face command to extract the upper edge of the parapet as a curve. Then I apply a 2 centimeter offset so the flashing has a slight overhang and looks more realistic. After that, I extrude the curve and the flashing is created. Of course, this model doesn't include detailed construction level flashing design, but for architectural modeling and visualization purposes, it is more than enough to read correctly in renders. And that's it. This is our villa. The main model of the project is now complete. From here, you can simply assign materials and move on to the rendering stage. If you're interested in how I set up the materials for this villa, I've created a separate video for material setup and rendering of this project. I'll leave the link on the screen and also in the description. I also added a few extra objects to the scene to make it feel more alive and realistic, but you are completely free to customize the space based on your own style and apply any design direction you prefer to the project. I'd really like to hear your thoughts on this. If you have any questions or anything that's unclear, make sure to write them in the comments. I'll try to respond to each and every one of them. If you enjoyed this video, don't forget to like it, and if you haven't subscribed to the channel yet, make sure to subscribe and turn on the notification bell so you don't miss the next videos in this series. And well, in this video, we went step by step through the complete modeling of a modern villa in Rhino. From importing the AutoCAD plan and creating the walls and floor, to modeling the pitched roof, terrain, windows, doors, interior spaces, kitchen cabinets, and even details like baseboards, parapets, and roof flashing. The main goal of this video was to understand the overall architectural modeling workflow and to see how a complete project can be built step by step inside Rhino. Of course, each of these parts can go much deeper and more advanced, and in the next episodes of this series, we'll gradually dive into more detailed work. So if you like this approach, let me know in the comments what you'd like to see next in the series, and which types of projects or topics you want me to cover. In the upcoming videos of this series, I also plan to gradually move into rendering and presentation, from introducing tools and rendering engines to how we assign materials properly, set up lighting, and finally create more realistic and professional renders. We'll also talk about presentation workflows and how to prepare architectural outputs for presentation purposes. So if you're interested in these topics, make sure to stay with the channel because more videos on these subjects are coming soon. Thanks for watching until the end. Goodbye.